Is it working? Are we live? I check here real quick. We are. I don't know why it shows up twice. It's kind of weird. Here real quick. We are. Sweet. Okay. Let me refresh that. Click to unmute. Alright, so we're live. I should now be able to hear chat if it ever comes in. So today I'm doing a quick stream on showing you guys an idea that's been running through my mind for the past week, and actually I've been working on it. And that is a motorcycle dashboard. I'm going to be completely replacing the stock one with a digital one, just basically a little 5-inch touchscreen type thing. Let's see here. So, I guess we'll get right into it. So I started looking around just online just for some ideas. So I got this. I always have little Google Docs for what do you call it? Just like projects I have going on sometimes. So my current project, my 2005 Kawasaki Ninja EX250F, whatever. Real cheap or good deal. I'm kind of rebuilding it right now, but I'm also in the process of. This is a huge portion of the project. This whole thing is my kind of notes on my Raspberry Pi idea. So I'm going to run through here real quick my program. Might not actually be that quick. We'll see. So I got this here. I got this. Stick that there. We don't need that very big. So, I decided to go with Raspberry Pi because a friend convinced me it would actually be not too hard. And so far, no, it's not hard. It's got a learning curve to it. Not too bad. I can usually pick up things like this pretty easily. So, I'm basically just using straight Python here. As you can see, I got some things folded up. So I'm going to run through this real quick. Let's keep these closed for now. So if you don't know Python, maybe skip this part. Or if you don't know coding, I guess. I mean, this is still going to be kind of interesting for people who know coding and whatever, I guess. But or anyone who's looking at this video after the fact and trying to learn from me. I was learning on my own, and the way I'm setting this up is because my motorcycle does not have like an OBD2 anything, and I was looking online, like people were suggesting, oh, I'm sure there's ways you can get your whatever bus, whatever, to hook up to your Raspberry Pi, and I'm not going that route. I'm going where I'm literally ripping out my current dash, and from the wires provided to the dash, I'm literally going to wire up to my Raspberry Pi, and I will be, in a way, I'll be basically just taking the inputs to the old dash and replacing them with digital, nice looking fanciness. So that's the way I'm going on this project. So if you want to just follow along here. So of course, if you're learning this, kind of like I did, I was trying to look up a lot of videos on like people who've done this. There's not a whole lot. I mean, there's people who show you that they've done it. There's people who show you like some of the basics. It's just like, oh, here's a a program you can download onto a Raspberry Pi, but it works with like only very specific cars. I'm just like, well, what? That's not very useful. So I had to learn this on my own. Not too bad. I actually kind of like this stuff. So it's hard to explain some of this stuff if I want to make this a quick video, but so you'll have to import some stuff. Basically this comes with Python, so just go download Python onto your computer, and this is not on a Raspberry Pi. Obviously you can see it's a Windows machine, whatever. But I'm just doing some of the coding before I even buy the Raspberry Pi to see if I think it'll be too hard or stuff like that. So far it's not looking too bad actually. So this is we're using Tkinter as our graphical program. And so now what we do, this is when some window setup. This says we're making a window. You can have Python do stuff in the background or whatever, but we're basically telling it, we're going to make a window. The title of the Windows dashboard, it is this resolution and this position on my screen. My font, these are some fonts I came back after the fact. There was a cool little program I actually found online. Either you can copy this or where did I find it? I can't exactly remember. Maybe I can find Python print out all fonts. No, these are really selected. I can't remember which one I was using. Oh, that would be kind of cool. Not print. I guess, I mean, that is. Yeah, I don't know. I can't exactly remember where I found it, but just know there's this little program, which if you run this, oop, why did it jump up there? That's weird. I might have to restart my let's see, Windows PowerShell, and we're gonna change directory, sorry, to desktop and Python. What was this one? Font. So what this one does, it's just a little program. It'll literally show you all of your fonts, available fonts to Python. And because it's on the Windows machine or whatever, it also takes a lot of the fonts from Windows. Somehow it like finds them. So this is, I believe this is actually going to be different when I put it on the Raspberry Pi. I could be wrong, but I decided that I am using, where was it? Agency FB, which is, let's see, it's kind of annoying because you can't actually scroll in this window, you can only use the sidebar. It's kind of like very, very basic. Or did I miss it? I think I did. Agency. Here it is. So this one, I thought this one kind of looked cool for the kind of modern look that I was going for. So anyways, chose that one. And they're just basically different font sizes. My font 2 and font 3. So now, this is just a real quick close button, which is just closes the window, which is triggered by this down here. I'm not gonna, here, why don't we quickly run my program here. So instead of font, it is dashboard. So this is what I have it going so far. It's running through a demo mode right now. This is just to kind of demonstrate to myself that it's actually going to look good and do what I want. I think next things I have to work on is odometer, and there's a couple other things I want to do. I can't remember. So this is that close button right here. You can see it just closes window. I'll tell you guys what all this doing later. I mean, obviously, if you know motorcycles, you know what some of that stuff is. So we got our RPM. So basically, the only way I can figure out how to keep basically a variable. Think of this whole function. This is kind of one of my bigger ones. This whole function, as you can see at the very end, it will loop every 50 milliseconds. So this is what this does. When dot after 50 milliseconds, it repeats this function. And the reason it's when is only because I named my whole thing, my window is called when. Dang it, I keep hiccuping and burping for some reason. Other people like to call it root for some reason, I'm not really sure why. So when after 50 milliseconds, we repeat this. So every 50 milliseconds this runs through. The thing is with things inside this, like, I call these functions, I don't know if that's a technical name, as again, I'm just learning this as well. I've kind of started picking it up pretty well though. This whole thing is the function, but everything inside is like a temporary. Every time you run the function, all these variables, they're all temporary. Like the one time you run the function, they're set, and then as soon as it's restarted, it resets everything. So the one thing you have to keep is the RPM. So you set the RPM outside, and then you call it in through, I want the global variable RPM rather than a local variable which stays inside the function. And then every single time we set our max RPM. So this is, I took a look at my original dashboard, and it just went up to 15,000 RPM. It redlined, or started the red line at 13,000. I think I just set it 500 below. I might adjust it a little back. We'll see. I don't know. And then shift RPM is something that I'm adding in as a, like, if you're going through your sport mode, or not, what do you call it? You're just driving around real fast, you're being all sporty, whatever, and you're just banging gears, whatever. You can see at this RPM, you'll see the RPM gauge will it'll turn yellow, and it'll just say like, oh, you should shift at this point. I believe there's something like this on some cars and things, some sport cars. It says like, oh, you should shift now, but it's before your red line, if that makes sense. So there's these three values. I can adjust these later if I need to. And this part here, this is the temporary part that's just looping through it, just as the demo mode. Later, this will have to be replaced when I can actually hook up like a signal in, which, don't worry, I'll explain later. Let's see. I've been streaming 14 minutes, not too bad, I guess. I'll explain later how I'm going to get these signals in, because they are, what do you call it? They're analog signals, whereas a Raspberry Pi can only accept binary signals. That's on or off. There are ways you can actually basically, what do you call it? You can convert analog signals into binary through these little tiny chips, which are super cheap, and then put that in through the Raspberry Pi stuff. So I'll explain that later. So anyways, this would be where I would instead of what do you call it? I think I would actually, I could replace this and this as well, and then replace this whole thing with the actual RPM value. Actually, it'll give me a voltage value in which I will convert that to an RPM, because that's actually how it does it on original dashboards. Something I had to look up. There's actually just feeds a variable voltage to your original dash, and depending on that dash or that voltage, it strengthens and weakens like an electromagnet inside your dash to turn your needle around, if that makes sense. So basically we just have to calibrate that. We'll probably at one point have to hook up both the stock dash and the Raspberry Pi dash at the same time to calibrate things and whatever. So this here, if I run this, see all these lines? This is what we're working on in this function. And it'll also change these numbers here. But all of these lines, every time this function is looped around, here, maybe we can throw that there, just have that up running. Every time this function goes around, remember it's every 50 milliseconds, it creates this entire set of lines again. So in order to not just cause a whole bunch of lag, we have to delete all of the lines, which are the RPM lines, which I have conveniently put into only 2 lines. So I'll explain these now. These are for I in range from 0 to, and this takes our, let's see, this is basically a rounding function because it only rounds down. This, let's see, what was, oh yeah, there was some, I forget why I had to do this. Oh yeah. Okay, so this was, think of this here. This is like a 270 degree turn, whereas this is like 390, so 90, 180, 270. So because I want this to be a 270 degree turn, I put in 270 here. I'll explain why it's actually 275 in just a moment. And we do it in steps of 5. And so what this does is with, let's see, so there's 270 degrees, and every 5 degrees there's another one of these lines. So you could spread these out or make them closer if you wanted with this. And the reason this is 275 instead of 270 is because the way this I in range does, it for some reason doesn't do the last number that you specify. So if you did from I in range of 1 to 10 in steps of 5, so think of this as one argument. This is the start, this is the step size, and this is like the max. And so if you did from 1 to 10, it actually goes 1 through 9 and doesn't actually do a loop with 10 for some reason. So I had to just throw on an extra 5 here because it doesn't actually do the last one for whatever kind of weird reason. I had to, let's see here, and then so we take our RPM, we multiply it by 270 degrees, you could think of it like RPM over max RPM, and that will give us a value anywhere between 0 and 1. We have to then multiply it by 275 to get our angle between 0 and 270, or 275. And the reason I have to multiply, because this in range, this has to be an integer. So we could have rounded without anything else. The reason we had to multiply by or essentially divide by 5, and then on the outside multiply by 5 is because it has to match up. Let's see here. It had to match up with our 5-degree increments. So if you change this like to 8 or something, you change all 3 of these, and just trust me, the math works out. I can't exactly remember why I had to do that. So this is from 0 to what our current RPM is. This one here, this is from our current RPM up to the maximum. So this is, if you think of this, the first for loop, this one here, does all the colored ones. This one here does all the gray ones. Oh yeah. The reason I had to make sure this was in increments of this is just so that it wouldn't, this wouldn't come out with a weird, there's like a half step left, what do I do, sort of thing. So anyways, I think that was probably the reason. It was something like that. So anyways, if we, so this, what this does, this is basically setting our color. So we have 3 different colors here. This here is the blue, is if when the range is in below our, our shift RPM that we set up here. So our shift RPM, if it's below this, then the color is this blue color. If it's between our shift RPM and our danger RPM, it's the yellow, which is this. And then if it's above the danger RPM, then it's red, which is this. And so now, because this is looping through basically all our angles, so basically now I does, oh yeah, I represents our angle from 0 to 270. We're technically starting 0 here. However, the cosine and sine functions here, these orient themselves let's see, how do they orient themselves? 270. Oh yeah. So they orient themselves as this, to the right is 0, like you would normally learn in your trigonometry, whatever, pre-algebra or pre-calculus class. To the right is 0, and then up around is positive. So 0, 90, 180, 270. So what we have to actually do is reverse this and say we're gonna say cosine of 270 minus I, which basically just means when I is 0, we're starting here, and when I is 90, then we're here. When I is 180, here, and then 270 is here. So that's kind of where that's going, and then we just have some math functions here, and we have to convert our angle, because I can much more easily think in degrees. We have to convert that to radians, because that's what the functions accept. So that's what this conversion comes in. Let's see, what was that? What else? And then, why did I have the floor? Okay, so that's where these come in, and then we basically take these values, these spit out their 0 through, or negative 1 to 1 values, like all cosine and sine functions. We multiply, so x naught represents the x position of the outside of these lines, and the xf, I call these x naught and x final. That's just the way I think of it in my head. The xf is the x positions of the inside of the lines, and then same with the y, which is the y positions, and instead we switch to sine, and we have to do 240 minus instead of plus for the y's, because the way the coordinate system on, like, when we plug it into this, we're going to plug these values into here, and we're creating a line. It says we're going to take the x and y initial positions, x and y final positions, and make a line between them. But the way the coordinate system for these work is your x is positive to the right, and your y is positive going down. So your origin is technically like up in the top left corner. So that's why we had to switch these around. The 240 is, if we think 240 is the origin or the center of our circle position, 240 and 240, so that's like right about here. And then I did, so these are all values. If you're having a different size screen you might have to mess with. My size screen, like I said, is 800 by 480. That's the size screen I looked up. That's the common size for a 5-inch screen. And then we're going to, so that's basically how you create all of these lines individually. Then we do the fill is equal to color, which we set up here. The width is at 8. Cap style I did round, and that's how you actually get these to look round on the ends rather than just cut off squares. And then I just tagged them as RPM line so that this here can delete them every round, basically. That's that. And basically almost the same thing for the gray lines, except we don't have to change the color depending on RPM. They're always gray, so the fill is just that. But same exact thing here. So that's all there is to the creating this part. Of course later we'll have our real RPM being fed into it. The reason I put plus 71 here, this increments it by 71 every time we go around this function, is so that it was like a moderate enough speed for this to go up and get a good idea, but I put it 71 rather than like 70 so that we could actually see this number here changing. Otherwise it would just always keep it 0. And this little thing here basically just says set it back to 0 every time we get to our max RPM, so that it just continually function or loops around. Now this is, let's see, what was this? There is a reason, wait, RPM position. Oh yeah. So what this does, this is the actual text value. See, we have 5 lines here, and there's 5 positions in these numbers. 1, 2, 3, 4, 5. Because it can go up to 15,000 RPM, so we need a 10,000th place. The reason I had to define these all separately, I could have put it all as, let's see, down here is where I actually define RPM numbers. This here, so we just have our this I created as, this is our number spacing. It's every 20 pixels basically is between each starting position of these numbers. This is the starting position, so that 5 pixels is where this first number is set to. 5 pixels from the left side. And so this is RPM text 1. This is the very first number 1, whatever there. This is the second one, this third one, fourth, fifth, and sixth. Actually no, this one, the sixth one, sorry. The sixth one is a static one. This actually is a little RPM sign here. So this, you can see it just says RPM. And this is the My Font 3, so it's a little bit smaller. A smaller 30, I think the rest is 40, and then the speedometer in the center is this one, the 140, so it's kind of big. What these are doing is this is actually taking our RPM and just singling out our, like each number position. So the first position will always equal 0 or 1 because we don't go above 15,000. So our first position here says 0, or once we get up to 10,000 and above, it gets to be 1, as you can see here, but it never goes above 15,000, so we don't ever see 2,000 or 20,000. And then that's what all of these do, is they just take our RPM and we actually subtract off our previous position amount, and then we divide it by that current position's what do you call it? Like lowest value. So like, so this is in the 1,000th place position, so we divide by 1,000. This was in the 10,000th place position, divided by 10,000. Just some simple math here to get these numbers for each position, and then these are all just simple if, else, if commands. We'll start at the top. So the first position, the fill, this is fill 1, fill 2, fill 3, fill 4, and fill 5. And these go down into our position. So as you can see over here, this doesn't turn white. See, it's like grayed out until the 1 shows up there. And if you see, it goes back. There's 2 positions that are initially gray, then this one gets filled, so it's white. Then this one gets filled, so it's white. So that's what this is doing. This is saying if the RPM is greater than 9,999, so that means if the RPM is 10,000 and above, then make this first position white. If it's then same thing, if it's above 999, then make the 1,000th place white. And if it's not above, then we set it to gray. So that's kind of these cool little one-line if-else statements, kind of cool. And these, what these do, these take your items from Canvas. This says things from Canvas. We're going to config them. We're going to config the RPM text 1, which is down here, and we're going to, because this is the text for the 10,000th position holder there. By default, it's 0. However, we're going to change it so that the RPM text 1, instead, the text is RPM position 1, which we calculated up here, and its fill is fill 1, which is over here. And it just basically does that for all the positions, and that is the RPM function. That took a little while. I'll promise I'll try to go through these other ones faster, and they're a little shorter too. So again, got our speed, set it in here. We're just incrementing it and looping it around in circles. This is very similar to how we did the text. It's like the exact same thing as this. So we're just getting the text for each position in the number. So if it was 112 or 123, I should say 123, just so that all the numbers are different and used. First position will be 1, the second position will be 2, third position will be 3. I doubt I'll ever get to go that fast on this little 250, but anyways. Then same thing, we just set our fill to white or gray, depending on if it's above 99, 9, or 0. Then again, we just changed our, speed numbers. So these are another setup here. So we got our speed number spacing, speed number start, and what was this one again? 132. Speed numbers, spacings, speed number, start. Oh, why can't I remember what these are for? Oh yeah. Okay. So this, okay, I probably should have named these a little better, but so this is the spacing between the numbers. This is the starting position left to right of the numbers, and this is the starting position up and down of the numbers. So it's speed number height is what I call it. These just do, so you got your speed, or this is where it starts. For the second one, you just do where it starts plus some the spacing. So this one, where it starts plus 2 times the spacing. That was also the same for up here, if I didn't explain that. Plus 2 times 3 times 4. So anyways, and then our fill by default is just white, but of course we up here modify it to be the fill is whatever we set it to. And the reason we can use the same variables fill 1, fill 2 as fill 3 as in the RPM one, as I explained, for each function, because these are only local variables, they get reset every time, so they won't affect each other, which is kind of nice. And then let's see here, RPM numbers. I got through that, got through the speed. This one, this is the, so these are all the brights, the blinkers, the neutral, the low oil warning lights. So all of these things, I'm just calling them in the light function. So initially we have a variable called lights is off. These initially start as grayed out. See, like this, they're grayed out. Now they're all in color. So these are basically my on and off. So when they're off, they'll be gray. These are all something I kind of took a while to figure out. These are, I had to import, no, I didn't. Oh yeah. So these are kind of a weird thing I had to do. So we're basically look at these for now and ignore these win dot, the same thing. We're creating variables which are an image file. So we have photo image, the file is these, and these are literally on my desktop. Where'd I put it? Might be on my other side here. Oh yes, here. Let me open up. Sorry. Alright. So we got these. And these are these images. I had to create these all individually. I may or may not. I might share this if anyone's interested. Of course, these will be very specific to this screen size. And if you design it exactly the same here, and I might, this is a GIMP file. GIMP is a free photo editing program, very kind of comparable to Photoshop. Has a lot of cool features, or a lot of features in it, but probably not quite as much as Photoshop. I've never used Photoshop. But you can do a lot of stuff with GIMP. It's free and it's nice. Looks like this little guy, or I guess that. So if you want to download, oh wait, I don't know, are you able to move this and then still open it? I think you can. I'm pretty sure if I just drag this out here, try and open it up. So I've moved its file location. I'm trying to see if it will still open just the same, and it will. Alright, so what I did is I took a screenshot of what I had at the time, and I started designing some little things like this. So I designed these four little icons, whatever you want to call them, lights, and then basically I did the other 4 as just grayed out grayscale versions of those same things. So there's 4 or basically 8 different photos here. If you want to just look, there's these 4 and there's these 4, which go right on top of them. So how this works is I exported these files or photos individually. So if I want to adjust the brights on position, I'd export that. If I wanted its off position, I'd export that. So I got all 8 of them in. Did I close that? No, I didn't. Okay. So I got all 8 of them here. I'm gonna throw this back. Actually, I'm gonna have to close GIMP here real quick. Just code changes. And let me know if anyone wants this. I might put it up somehow. I'm not really sure how. I might link it through a Google Drive link or something like that, but means I gotta leave it there forever. We'll see. So if anyone comments that they want that, I might throw it up. So we use those images. Let's see, we import them, we assign them to a variable. So basically, the reason I am throwing these outside, I could have thrown them inside the function. So every time the function loops around, it defines all of these files. Except that I noticed was actually getting, like, it would stutter every time I noticed these would turn on and off, because it was basically just loading. It was loading these every single time. So when it's outside the function, it only basically loads them once. At least that's from my brief understanding, just because I actually could see the lag spike hit it. I don't know why it lagged every time. It's kind of weird. My computer should be able to handle that. They're very, very low resolution photos. So it basically loads these every time from here, the image folder, and these are all these. The reason I had to do these is because otherwise, I guess Python will, the way tkinter or whatever is set up, is it will like garbage these as soon as you're not using them. So basically it would just unload them. So if you define them as a, I don't know what these are called, a class? No. Was it a class? It might have been. You define them like this for some reason and it won't throw them away. And so basically all we do is we import, let's see, first we start off with deleting lights, anything with tag lights, with the tags light. Oh, you know what I just realized? I have to create an if-else for every single one of these. Not, okay. Okay, so this is because I was thinking in the mindset of turning them all on and off simultaneously. Whereas in the real life, you know, you might have blinkers on, but obviously you won't have a neutral light on, or you shouldn't have your low oil light on very often, hopefully. So I have to define these all individually, put them inside their own if-else statements. That's something maybe I could do kind of quick here, but we'll see. And then, so the if-else statements, this is basically just looping through them, turning them all on, turning them all off at the same time. And this is the an if statement turning the lights variable on and off. So lights, if it's on, or if lights is on, then turn it off, else turn it on. That's kind of how that works. It's kind of a weird syntax for if else inline statements, but I guess once you figure it out, it's not too hard. So that's something I'm gonna have to fix. They shouldn't all be linked together. And in real life, you won't just have a single, or when we actually hook it up, it won't have just a single lights or on variable. It'll have one for each of these, all four of these lights. And of course, if you have more lights and dash things, you can make more. You'll just have to design your own lights or the little buttons and things. That's basically that. So this basically creates an image every single time rather than like replacing it or modifying it from something down here. If that makes sense. So yeah, that kind of just worked out a little easier. And then the temperature, this was something I did. I have to drag this out just a bit. The temperature, this is this dial. I had this just kind of, it starts off low as if you just started your bike and your temperature sensor isn't sensing the temperature yet. But once it starts to get up to a level, you know, so it says, so in the middle here, this is like your normal range. This is like cool range. And this is getting to hot range. They're up in the red. And basically, this is kind of similar how we did this, except we have, instead of using cosine and sine functions, we just have a linear thing, so we can just set, I used XOT because it's X naught of the temperature one. This was just something, I could have just used X naught, Y spacing, and this is what, XF. The reason I set all these is so I can actually go back later. Like if I don't like my spacing, I can change this. I kind of like my spacing now, 15 pixels apart, whatever. N is the number of lines. So I could set this higher if I wanted to. The warm temp is where it goes from blue to yellow. Hot temp is from yellow to red. Max temp is like just defining the very, very top line. Our minimum temp is defining down the very bottom line. So we import temperature again. We increase it by 5 each time we iterate, which is every half second. If temp is above max temp, then we set it back to 70. So this is just kind of saying 70 degrees Fahrenheit, which is kind of like a room temperature or an ambient temperature, I guess I should say. This is just kind of what was in my mind. These numbers were kind of, I just made these up because like on my motorcycle it just has a dial with like here's high, here's low, here's in the middle. There's no actual numbers, so like I kind of just made these up based off of what I know my truck runs at. My truck idles around 186. I can tell a difference between the power band, the actual the ECM on my truck will limit my power just a little bit. Like I can't gas it really hard when it's below 140, about there. It idles in its normal operating temperature 184. At the max, the max normal temperature, like I was driving through a desert, it was around 200, and once I've seen it up to like 209-ish, I think. That's like the highest I've seen it. So I just set my max temp at 220. So the hot range is from 200 to 220. Min temp, I just said 20 degrees below 140. So that's how I set those numbers, if you're wondering. Now, big N, the big N I represent as the number of lines that the current temperature is actually at. So if we take our temperature, we subtract off our minimum temperature so that we have our, what do you call it? What is it? How do I word this? This is if the temperature was at our min temp, or minimum temperature, then that means that we are 0 basically on this dial. And then we divide by our max temp minus the min temp. So we're basically taking our range, we're taking our current temp, dividing by our range, and then we multiply, so this gives us a value between 0 and 1. We multiply that by n, the number of bars or lines we want, and then we just add 1 because of that same reason, because we're throwing it into the range here. I could have done n plus 1 here, or I guess n capital 1 plus 1 here, and this goes from basically another for loop, starts from 1, goes to n in steps of 1, and then basically we have another one of those if statements to set our color, just very similar to the RPM. It creates what was this one? Oh yeah. So this basically creates the colored lines. Then again, we have the same sort of stuff as RPM. We go from our current temp to our max temp, which is, or max temp in this number of lines. And this is just n number of lines plus 1, remember. And this just creates all the rest of the lines in gray. It just repeats every half second, so that's that. I probably should have thrown this before our functions, or just explained it before functions. This is we're creating a canvas. So this up here, this is creating like the window, and to be able to actually do all this graphical kind of stuff, you have to make a canvas within the window. Otherwise it'll just display like plain text and things like that, or whatever. And so we create a canvas inside our window. Its width is 800, its height is 480, its background is black, otherwise it would just default to white. You have to set the border to 0 and the highlight thickness to 0. The reason is because otherwise it'll put a little white border around the entire thing, which kind of looks dumb. And then basically this is saying put our canvas somewhere. Just basically pack it inside of our window. So that's what that does. And this again, this is RPM numbers, speed numbers, the coolant temp. Oh yeah. This was, I thought I would need the coolant temp numbers. I might throw that in there. Just like list the number up at the top here. That might actually be kind of cool. The only thing is I don't actually, because I made up those numbers, it might not actually be that. So yeah. And then these here, these just start our functions. So on their own, these won't do anything. So you have to start them, and then the function will loop themselves. Or let's say this one. See, at the end of all of these, they loop themselves that way. And that's pretty much it. And then I have my close button. And this is basically to say to the computer that keep our window open, if you want to put it simply. Otherwise it'll flicker our window open and then close it immediately, and you'll not actually see it because it's as fast as a computer can go. So yeah, so I can close this, and you saw how long that was running. It wasn't slowing down like I was having. Actually, before I figured out to put these in here, actually not the speed, anything with graphical stuff, not just numbers, like the lines or the photos, the actual photos of things. I was starting to get laggy after a while of leaving it open just for a while, just doing some testing. And it was because it was literally just building up on top of each other over and over and over. And so it just got super slow, and so I had to remember I have to remove these things every time, otherwise they just stack on top of each other. I think that was all about it for the code section. Sorry, I've ran on for almost an hour. Holy crap. I do get carried away explaining things sometimes. So, imagine this. And now we're going to put it in an LCD screen. So, this was something I was doing, or looking up a little bit, done a little bit of research. And I want to do a 5-inch, I think, is a good size. And that's like one of the common available sizes for like Raspberry Pi stuff. This, there's two types of touchscreens. There's resistive touch and there's capacitive touch. Most devices that you have, like your phone or any touchscreen laptops or tablets, they're going to be capacitive touch because they're generally more accurate. The only problem is that you can't use it through, or you can't really use it through like motorcycle gloves unless you get the specific kind. And if I ever get caught in the rain for whatever reason, which I also plan to make this thing waterproof, somehow, we'll see. If I ever get caught in the rain, the capacitive touch ones will, like the raindrops on the screen will actually set it off. And so it'll just like be touching stuff all the time, and so I don't want that. So I get the resistive touch, which you can literally, it's like done through pressure. You can literally touch it with anything, and hopefully water on the screen won't set it off. So that's why I did this route. So this one, there's a couple different options. So there's this one, the Waveshare, whatever. This one I think is the one I'm going to go with. And I'll explain some reasoning later. The reason here is, or one of the reasons is it's the resistive touch. It's 5-inch. It's done over HDMI. So you can see you just need the HDMI cable and the power cable / touch information cable, which will go to your Raspberry Pi. So it doesn't really show it well, but this cable here loops around back into your Raspberry Pi. It transmits the power to your screen, and it also carries the touch screen information, which doesn't go over HDMI. So and then this just shows that actually no, this loops around to the top, so this goes into the USB. This is just power for your Raspberry Pi. So you need something powerful enough going through this cable to power the Raspberry Pi and the screen. Which should be too hard, I hope. Should just be like a what do you call it? Like a cigarette lighter adapter type thing inside a motorcycle. I don't know, we'll see. It's a USB. Or maybe I'll just hardwire it to actually I don't know, little converter blocks. I'm sure you can buy USB little things. Anyways, you have to have it down to 5 volts instead of a 12 volt system. So there's that. One of the reasons I didn't go with, there was, what was this one? This is, I think this is the same thing. There's just a video and manual. Okay, so that was just my documentation, sort of. This is a video on someone kind of hooking it up, except it's a different style. Much more like this one. So this was a different one I saw earlier on. Okay, why is this so huge? I think it thinks I'm on mobile or something. Can we not be in a mobile version? Okay. Well, anyways, so this is the other screen. Looks very similar, but I don't know if you can see this. This is a... How do I... There we go. Just gotta drag it. So this is a little HDMI bridge, and this literally makes it so that you can hook up your Raspberry Pi directly underneath the screen. The only problem is, see, this is your Raspberry Pi underneath. This is your screen. There's that. Oh, they don't show it. There's like videos of people putting this together on this specific one, and let's see, where is it? The back side. God dang it. Okay, this might be easier to see, at least for my eyes. So this, they have a bunch of the GPIO pins on the Raspberry Pi taken up. So these are all the pins where you can go your in and out. The reason I didn't want to go with that is because I need to be able to do something that takes the analog signals and puts them into digital, like I was talking about earlier. This was just some videos on myself learning the Python. Was this? Oh yeah. So this is something I'm gonna have to use. Where is it? Okay, so this is the analog to digital for the Raspberry Pi. And what this is it basically, you can take like your varying voltage values of whatever my dash is going to give out, which I'm going to have to go down and basically test with a multimeter and see what they actually put out. But I'll be able to take those analog signals, which are basically just giving you a voltage between 0 and probably 12. If I'm just going to guess, it's probably up to the battery voltage. And so what you can do is there's this little guy here. This little pin will convert analog signals into a digital signal, like a bus, something or other, and then you can basically take this and convert it, or once it's into that signal, let's see, so this is that little tiny guy. It converts analog into, you can see it's pretty cheap, $3.75, into the digital. Then you need, if you were going to use this as a project for something, you can get your little knob, but we're not going to use the knob. We're going to use our input from the motorcycle dash cables. And if older 26 pin, yeah. And then we need to use this, which will basically take, we can, if we do like to the proper pins on this will plug into a breadboard, in which I've heard there's things, they're similar to breadboards, but you can actually permanently solder, which I might have to do. And it takes this and plugs it into the Raspberry Pi. The only problem is this takes up all of the pins on the Raspberry Pi, which is why I couldn't go with this model of the touchscreen thing, is because this takes up about half of the pins. However, this thing takes up all of the pins, so I had to go choose between one or the other. It takes up all the space. You don't actually use all these pins. You only use a few of them, which is kind of dumb. However, it might be the only good option for the moment. And then, let's see. This says you'll have your full-size breadboard, but I'm gonna get one of the ones that you solder or something. And then breadboard wires. You could probably use like almost any wire as long as you can actually get it inside these holes just fine. And properly color code or something, label them. So this basically so this converts it to a digital signal goes into your Raspberry Pi. And then there's some coding, just a little bit of coding. You're gonna have to make sure your Raspberry Pi is up to date. You're gonna make sure you have pip installed, and apparently I don't exactly know what pip is, but then you use pip to install the code, like all the backwork stuff for this little chip, and then you have to install there's like a couple things you have to install. So you have to install this and this. So then inside your code, all you have to do, this is an example for changing your volume. So they had to import a couple other things like OS, digital IO. Actually no, this is something I think you have to do with, what was it? So let's see, CS. I was looking through this earlier. It doesn't look too hard. So you basically have to import a couple things. I think you have to import this. You have to import digital. I think you might have to do this. Then this. And these. So what these then allow you to do is say your SPI. Let's see. This basically says we're creating the bus. And if you don't know really what a bus means, computer stuff, it's just like, the way I think of it is it's like a digital plug. So it's like the system that reads digital info. So you're creating a system that creates, or that can read the digital output from this little tiny chip. And you set up where that signal should be coming in, which is, I guess, D22. And then you create an object for some reason, I don't know. But you'll basically follow some of this code, and you say analog input from these things, and then this is basically your variable, and you can say, I want my variable's value here, just channel 0 that value, or you can get a voltage, I guess, as a string. So there's a couple things I might have to tinker around with once I actually get this physical hardware going. And so I guess you can literally just throw in your dot voltage, as a variable, which is kind of nice, which is exactly what I need to then throw into my code. And the rest of this stuff is just basically for the example that they have here, which is change this knob to change your volume. So I would then take those values and literally throw them in here in my RPM gauge, and then do some conversions to get them to the RPM. Like, I'd have to do some calibration, I guess. Just basically just a multiplier. I would hope. I think it's linear. At least I would hope linear. So there's that. That's how I'm going to get my analog in. Then there's someone that had pointed out so that the Raspberry Pi can properly shut down. Because if you literally just turn off your bike and immediately shut off power to your Raspberry Pi, you're gonna probably mess things up. Just like a normal computer, you don't just pull a plug on it. You actually have to go over here, turn it off, whatever, properly, so it can shut down, save things, whatever. So that's basically what this little thing will do. It's literally a 3 amp car supply switch, or whatever. So what this does is it basically senses your ignition and safely shuts down the Pi. So it basically will basically, once it senses that your ignition is off, this thing is still technically powered through there's like ground, there's your ignition, and your battery live. So technically this thing's always connected to a 12-volt source or whatever, but it's also connected to your ignition so that it can sense when that's on and off. And when it senses that it's off, it runs off of the 12-volt source to then turn off your Raspberry Pi properly. And I think it just does that through USB, which I think is kind of cool. It says, I think there's somewhere it just says you just do a quick install on the Raspberry Pi, some code, so that it will properly be able to read from this thing and say, okay, this thing's telling me to shut down. Let's shut down properly, whatever. So that's that. So that's a cool little thing I found that will make this project a little easier. Oh yeah, and the last thing. So the thing on my dash, the speedometer is controlled by. I don't think I have a photo on my computer. Let's see if I can just look up Revzilla. And this is actually where I've been finding a lot of the OEM parts for my bike that I'm fixing up. Where was it? Wheel and axle. Front wheel. So the front wheel has this little assembly, this thing. I'm not exactly sure how it works. But basically, imagine there's a little, what do you call this? It's kind of like a brake line or a clutch cable. I guess it's closer to a clutch cable type assembly that comes off of here, screws on this end, and goes up to the dash. But what's inside is like this cable that is able to spin around. And so basically, it spins at the RPM of your wheel, I'm assuming. And so, through this basically spinning cable is what controls the speedometer through this really weird mechanism. I'm not even sure exactly how it works, but the spinning cable then makes your speedometer raise and lower depending on how much it's spinning. And so basically that whole system is kind of useless to me. So I'm just going to basically unscrew this cable, get rid of it, patch this up so things don't get in there and start rusting out or whatever. But then instead, because that system is kind of annoying to work with, just basically getting a spinning signal into a Raspberry Pi would be kind of difficult. So instead what I'm going to do is get this, which is basically just stick a magnet on your wheel, and this little thing will sense whenever that magnet flies by. And it will, essentially, I'll be able to basically code this in and see how fast this is pulsing and do some calculations on the, what do you call it? Basically just do a little math on the radius of or the circumference of the tire and the RPM at which it's spinning, and then do some math to get it into miles per hour. So that's what I'm going to do for the speedometer. And that's pretty much it for the dashboard section that I have so far. So obviously I've been streaming a little too long. This is, I guess, a fairly in-depth kind of setup. This is just like me starting off, and I'm learning on my own. This isn't exactly a how-to, but it's like it could be a pointer in the right direction for anyone else doing the same thing. Obviously try and watch the later videos to see if anything changes or if this fails. This could be quite a while till I actually get around to finishing this project. Money's a little tight right now, but we'll get there. So I gotta actually make the motorcycle run first. So yeah, I think that is pretty much my project. Let's just run it one more time, show you guys, and then I'll be off. So yeah, basically once I get those signals in, I'll have to come in here, obviously do some more coding, do some calibration, and it will all look good. But this is a lot of the setup. And yeah, I guess these will all stay the same. I was thinking, so I'll be able to get rid of these. These are RPM values out here. These, whatever. However, it's I don't know. I won't be able to remove these, obviously. So I don't know what I was going for there. Getting kind of tired. Anyways, I will see you guys later, and ciao. Am I still streaming? Wait, I better be. Huh? Wait, oh yeah. Duh, I'm using OBS because NVIDIA didn't work. I scared the shit out of myself. Okay. And see you guys later, and have a great day.